Oke, semuanya sudah siap. Eh, Cuma sepertinya lampu saya agak redup ya. Saya juga baru sadar ketika akhirnya memulai meeting ini. Sepertinya memang saya perlu ganti gitu. Eh, Namun setidaknya muka saya jelas terlihat, suara juga oke, materi sudah siap. Sekarang pukul 18.28, kita tinggal tunggu anaknya untuk masuk gitu. Tadi sih emang confirm orang tuanya bisa datang sih, nggak mengatakan kelas diundur atau apapun. Parents cuma confirm kalau masih menggunakan link yang sama atau tidak. Dan saya setelah menjawab, iya, nanti kita coba tunggu aja ya, kira-kira dia akan bergabung jam berapa. Sembari saya coba komunikasi sama parents ya. Oh, udah datang. Yuk kita mulai. Let's get this. Alright. Hello, good evening. Is everything good? Ah, hello, good evening, Widi. Seems like you're just having a shower, right?
Yes.
Uh, do you want to, you know, a bit
Uh,
trying to
no, no,
have
sah.
a sharp look?
No, no. Okay.
Okay. Do you just arrive at home or just done with your stuffs before?
Mm, my brother bisa ditulis, so I have to wait for him.
Ah, I get it, I get it, I get it. Okay, cool, cool. It's really good to see you that you already taken the shower. Ah, thank you, mom, for helping out. Okay, we did.
Cocok banget ini.
Okay, that's okay, that's okay. I thought there was something missing or maybe errors that you guys encountered. That's why I am a bit worried. Luckily that you just finished your shower. Good, good. All right. Uh I think that since that we already passed about 10 minutes, I think we have a bit limited amount of time. So I hope you don't mind if we try to straightforward to what I'm gonna teach you about tonight. So, okay. Now, we have already share a lot of things about we try to measure the perimeter of certain areas, which was actually part of the lesson when you were like fourth or fifth grade, right? Uh, right now, I'm gonna try to combine it with another lesson, which is the area. Not sure. Do have you ever already learned about how to count or how to measure the area of certain geometry, something like that?
I think you times the height and the width. I think the length and the width.
Uh,
Maybe
but in case that you measure for example like rectangle, what's the area inside of it? How to measure it? Not the perimeter. Yeah, perimeter was talking about the outside layer, but now we are talking about the inside layer. Have you learned about it at school?
I learned about it, but I only remember like when two times the two sides.
Hmm, I see, I see. Okay, so let's try to take a look deeper to also refresh to what you have learned at school. Hopefully that it would be useful for you as well to continue all the lessons, especially in school when we are facing a more complex geometries as well as trying to combine it with uh more unfamiliar lesson that you might be facing in the future. All right. So we try to have a certain scenario that actually when every family at the campsite, they actually conduct a kind of event, a kind of party where everybody gather around in a hall, for example. And then in that place and that forest, there is a hole that actually a bit dirty, I can say, a bit dirty. That's why that ranger that we already met before in the previous lesson would like to ask for your help if you could help him paint to paint the hole. That's why when it comes to the correlation with the area, right? Once we already learned on how to build the fencing, build or maybe trying to fencing all the outer layer of each tent. Now everybody's safe. Now means that everybody could focus to just have a good time with their family, trying to know each other with all the neighbors, all the families that actually attend that event. And somewhat at the night, they actually try to attend kind of a party in the camp hall. But unfortunately, you found that uh, the wall of that camp hall actually dirty. That's why we need to repaint that. That's where it comes to the content of the area. Differently, talking about the perimeter, we often put it a symbol where perimeter was defined by P, meanwhile the area was A. That's the common thing. In Indonesia, we try to define it as keliling as well as L, as luas. Sorry, it should be in the inside. L refers to luas. Now, the kind of what I was talking about is quite similar to what I also display right here, where actually for every outer layer of certain shapes is actually can be called as the perimeter. Like for this example, for this triangle, for the rectangle, for example, we already learned about the width as well as the length, right? That's two elements which is not only really functionable for measuring the parameter, but we still need to have them to measure the area inside of this rectangle. The difference is if the parameter is on the outer layer, the area should be something inside, should be something that we need to measure inside. Now, the difference is when it comes to the parameter, we recognize that there are actually two widths and also two lengths, right? But in this case, for this rectangle, it comes to only one side that we pick, only length, only width. We don't put any two times of length and width. We also don't use the addition, but instead the multiplication. How is that so? Because first, not only we try to measure the inside layer, but also the unit of measurement of every area should be in square meter unit, square meter unit. And this could only come from the multiplication. Okay, let me try to give you an example. If let's say that we actually have four blocks, as we try to call them as length, right? Something that refers from left to right, as well as we have two blocks, something that we refer to the width itself, right? So it's four, this one is two. And then if we put on the same measurement unit, like 4 meters as well as 2 meter, right? The way that we try to get the square meter unit as part of the unit of the measurement for the area is to use the multiplication. Sorry, let me try to rewrite it down. So if I rewrite it down, 4 meter multiplied by 2 meter, we are not only calculate 4 times 2, but also meter multiplied by meter. Okay, so it would be 8 since there are 2 meters. That's why we put square meter. Now the question is, why don't we put like 8 plus 2 meter? Okay, that's the basic question because we already have the logic that there are actually 2m, 2 meters, right? This one is the first m, this one is the second m. Why don't we then just put it 2m? This is something that actually you would learn when you were and when you are entering seventh grade. But let me tell you something. If we try to find 2m's, the calculation would not be like this, but instead m plus m. It's similar. When you have an apple and then you have another apple. That means you have two apples, right? It is similar when we try to calculate m plus m. The result is 2m. But when we try to put it as the multiplication, m multiply by m itself, it would go as square meter. It only applies when we are having the same thing that we want to that we want to multiply. The different result would give you if let's say each other is actually in different measurement unit. So let's try kilometer multiplied by meter. These both have m, but actually kilometers is km, so what we call as a symbol k and m, and the m right here is actually standalone. There is actually kind of measurement unit called meter, right? That's why it cannot be written as kilometer per second or square of the kilometer is not also kilometer to meter. No, not like this. But instead, since kilometer and meter, even if they are in the same measurement unit, which is we try to measure length, right? Kilometer, hectometer, decameter, meter, something, so on and so far. Remember, right? Even if they are on the same measurement unit, but they are actually still different. So we just only write it less like kilometer, meter. If the same measurement unit cannot be put all together, what about the different measurement unit? For example, when we try to measure the volume, right? There is a measurement unit called as liter, and then we also try multiply it by meter as the measurement of length, right? The answer for this kind of multiplication would be liter, meter. Ah, do you understand as far as I explain this?
Some of it, yeah, some of it, no. Like the meters, I kind of understand. Like the I don't understand.
Ah, I see. This kind of squaring things only happen, or squaring things only happens when same symbol
Yeah.
is multiplied by the same symbol. Okay, so let's say liter multiplied by the same liter, it would be square liter. If there are three liters that we actually try to put as multiplication, it would be ah they are kind of like exponent, what we call as the highest student, maybe exponent, or maybe in Indonesia we call it as pangkat. Ah, pangkat, since we are trying to multiply the same symbol to each other, but it translates to a different kind of things. Depends on the situation. In what we are learning today, what we are learning today is square meter is the valid standard. Is a must. Is a must standard. So when it comes to every kind of exercise, especially for kind of like options exercise, there are four options for every exercise, for example, right? The first thing that you need to be certain is once you know already that that exercise was asking you about how to measure the area, what's the area of certain shapes, certain geometry. Each answer actually should be distinguished. If let's say none of them or only one of them actually have this kind of measurement unit, square meter, or it can be translated to meter pangkat dua. It can be differently in writings, so the rest doesn't matter. Okay, so you get the first clue already. But if let's say all the measurements of those answer already on the same of the measurement unit, it can be centimeter, it can be kilometer, something like that. Depends on what kind of information that already being known at the beginning, right? But the basic things that you could recognize is the measurement unit for all area should be square unit meter. If the volume is the cubicle of that measurement unit, what's cubicle? Cubicle is it also refers to the volume. That's the different thing. Area is square meter, volume is cubicle meter. Okay. Now, that's why, since that we are trying to have this kind of measurement unit as the standard, that's why we put the multiplication instead of addition. Okay. So there's a difference. Even if on the same shape, even on the in the same shape, we use a different formula. At once, we try to use the addition as the way that we try to put the parameter, but for the area, we try to put the multiplication instead. But the information of the length and the width, it's still necessary, okay? Because we try to measure what's the inside. Another way to know or to be certain what formula that we could use for each geometry or each shape. That's the kind of thing I'm gonna teach you moving forward. Okay, this is the example. How do we actually measure the area? We could actually count all the squares inside of certain shape. If let's say all the shape is actually being built or being placed in the Cartesian grid or the transformation grid. Okay, this is something that's really familiar for you, I believe, is we just have to measure how to count, sorry, how to count how many blocks that being blocked right here. There are like five. The row, each row is similar. So there would be five multiplied by three. Do you understand how it comes?
What? How it was?
Do you understand how I put five times three?
Maybe because there's like five blocks on like the length and three blocks on the width.
Yes, as well as I'm not sure if you remember for second grade lesson when you try to tell the kind of like multiplication in way that you try to group them up, right? We just have to count how many columns that they have, how many rows that they have. Do you still remember that? What is row? This one
Row, yeah,
or this?
row. Row is like the the vertical one.
Row is vertical and
Yeah.
column is the horizontal one.
Yes.
Okay. So uh row is actually from left to right. As long as there is the next guy standing next to you on your left or on your right, it call it as the same row. So there is like three rows, right? This is the first one, second one, and the third one. Column means vertical. There are like five column right here. Correct me if I'm wrong. That's why we just can put it as like 5 times 3 or 3 times 5. That's really relative, but the result will be the same. For as long as uh we find that the result would be 15, I think that's the justifiable answer. Now the question is, Lo, previously you already said that uh we have to maintain the kind of length and width information. So then why we have to use column and rows method instead? Okay, first is about since that it is quite similar pattern for us to recognize. It's like a table, right? Table, there is column and row. There is column and row. And the second one, in the case that you are having a really complex geometry, but they are actually standing or being placed in the transformation grid like this. Remember, X is the horizontal one and Y is the upper side. Remember? Uh, this is the kind of same thing. Oh, sorry, X right here, Y right here. This one is 0. Ah, if let's say that you don't have any information, length and width, especially if geometry being placed in a transformation grid, but you don't recognize what kind of shape that is, right? Counting blocks, recognizing pattern, columns, and row would really, really helpful for you to measure the area of that geometry. Ah, how we define 1 square meter is if I just block one like this. This is what we call 1 square meter. In another word, it also can be defined like this. If let's say for each block refers to the position, okay, and then this area is what we call 1 square meter. This one, two, three, four, and five, so on and so forth. Okay, so that's how we tell uh the square unit. Now, as for easier way for us to identify the way that we could measure a certain area for a certain geometry, right? Using the method rows and the column would be helpful for you because anyway, it would give you the right answer, the same answer when you try to count it manually. If you don't like it, the way that we put row and columns, just count it manually inside of any geometry that is being placed in the transformation grid. If let's say that kind of shape is really, really firm, there is no intersection that cuts, that blocks your way to count it. Let's say that, okay, there is a triangle right here. So there's only like, I don't know how to measure it. Can you tell me if let's say I build a triangle inside of this, what's the area for that? Ah, like this. Can you tell me?
Um, I think it's 1 block because the triangle is like between 2 blocks and then it's half. So like 2 half plus equals 1, I think.
Yes, correct, right? You can actually still use the old method, try to count how many blocks that being used for that triangle, right? Says that it was being cut in a half. That's why we can count it. Ah, but if let's say that we are facing really complex, the combination of shapes, and then we try to measure them all, right? Using the way that we try to understand rows and column, or trying to understand the pattern for each shape, it would be definitely very, very useful. Like for the rectangle, like I tell you previously, right? For the rectangle, the way that we measure the area is width multiplied by its length. That's the area. Can be said length is row, can be seen. Width is the column itself because width standing in a vertical line, length standing in the horizontal line. Okay, now it happens to all rectangles without any exception, yeah. So all rectangles actually can apply this formula. But for square, it's actually using different formula, but the concept of the way we try to measure the area will still be the same. It's either you just count all blocks being placed, all blocks that was being blocked by a certain shape, as well as trying to count all the rows and the columns. Like for this example, if I try to put a different measurement for your floor, your wall, on your back, or maybe on your path that actually contour like a rectangle shape, it's actually something that we could measure in the same way. We just have to know the width, we just have to know the length, right? And then we just try to count it up, right? The different thing happen if let's say uh the shape is actually a square. Wait, I cannot play it. Okay. Can you tell me why we couldn't use width multiplied by length as what we already know in the rectangle formula into the square itself?
Mm.
The first reason is about the characteristic. So what's the difference between the rectangle and the square?
A rectangle is the length is sometimes like longer and sometimes the width is longer, but the square it's all equal.
Correct. For square, it's all equal on each side, right? I can try to mark it like here, like this. Meanwhile, for all rectangle, there's only one side that's actually equal. Length should be equal to the another length. The same goes with the width itself. But we can be certain that actually length should not be the same with the width itself. That's why I put it like this. This is quite a unique symbol in math. where we try to divide, not equal. But in this one, since that each side consists of same length, we call it differently side. Okay, but the way that we actually measure the area will still be the same, right? Since for the rectangle, we just only have to get one information. As long as we get information for the length and width, right here, we know how to calculate it. Just multiply it, and then we find the area for the rectangle. But for a square, we only need one information, the side itself, because eventually each of them would be equal, like you said. Ah, that's why we put the area for square should be side multiplied by side. Back again, why we should use the multiplication, because we have to find this, the unit of the measurement. It should be the square meter, square kilometer, something like that. It totally kind of really distinguish the measurement unit that we can actually use. That's why we use side multiplied by side. Okay. Now, before I continue, do you have any question before I move to the triangle?
No,
No? All good?
it's
Okay. Now, for the triangle, it's actually something I can tell as the half of the rectangle because it's just easier for us to see it that way. So if a triangle, we try to intersect, we try to cut them in half, but diagonally, right, from this point to this point, we just draw the line, right? You can see this as a triangle. The other half is also the triangle. Can we do it? Can we do it inside of the square mass? Yes, you can actually also do it in a square, but both actually have the same pattern. In a triangle, you already recognize there is something we call height and also the base, right? Height is actually the vertical line to the top of the triangle. For the base, it's just something like, yeah, we call the line from left to right, right to left, whatever you wanted to say. But differently saying that when we have length and width in the rectangle, side on the square, we have height and base in the triangle. Now, we try to have kind of like the way to measure the area inside of this triangle, right? But not all exercise, especially talking about a triangle, was actually being built outside of the transformation grid, right? Sometimes we cannot count either way. If let's say one block of the transformation grid and then somewhat the triangle cut it like this, inside of this, we cannot tell how many blocks that being occupied by that kind of line, right? So that's why the method trying to count all the blocks for all being you know being blocked by a shape, it's really hard to count. But basically, when we try to understand the formula and how it comes to that kind of thing, is we is something that we can use right now and in the future. For the triangle, is we just have to multiply base and height. But how come as there is like half, like on the factorial number, there is half of the base and the height. Can you tell me? Let's say maybe you figure out something. Why do we put half multiplied by the base and the height?
because like once you multiply like the area, so like it becomes like the normal rectangle, and then like you divide them by half to get the, how do you call it, the answer for the triangle.
Correct, correct, awesome. Okay, I just want to put it into a better one, trying to add couple of things. When you say if I just calculate base and the height without dividing it by two, I would get the area of the rectangle instead of the triangle. Okay, the first thing it's not a division. Uh, if let's say that you divide by half, it would be written like this: base, height, and then you divide by the half. That's the way we write it. But in this context, you can just say that base and height is multiplied by the half or divided by two. You can straightforward of it. That's the kind of thing. So it would avoid a confusion when you try to rewrite what you understand in verbal versus to what you already recognize and remember on your visual. It also would be helpful for you when it comes to a different understanding between you and your teacher. It happens a lot, even in the highest grade of school, in math, especially when we talk about certain formula, especially in English, we are very hard to recognize the concept or maybe the way we explain the math formula, and somewhat we are lost in the translation. So that's why I try to help you in this kind of context. For this one, when we try to tell that actually this is the half of a rectangle, we just simply say it is just like being divided by two, or we multiply it by half. But the total explanation, if this is being explained correctly, is absolutely right. As you can see that actually I start the triangle from the rectangle itself, right? If I put it the half factorial right here, it's totally only base and a height, which basically looks similar to the rectangle itself. I only have the two elements, right? It would be 40 square meters. That's why to get an accurate answer, I try to back to the concept. Triangle is the half when I use a rectangle as the simulation. So that's why I put it halfway as part of my multiplication. Okay, that's the kind of thing. Would it be applicable for all triangle? Yes. For as long as you actually have the information, height and the base, right? You could actually measure that area of triangle. It would apply the same. Now, let's refresh a bit. What's the area of a square? How to calculate it?
You times the length by the width.
A square
For a square, the square just like times the side
with
width. I don't know.
times the side with.
Width like the measurement, like the, like how many, I don't know how to explain it, like it's basically like the rectangle, but it's just like the square.
Yes. For let me help you to explain that. The area of a square is side times side. So it won't be set as like a side multiple by four, because that's the way we actually measure the perimeter, not the area. For the square itself is side multiplied by side, or something that you could eventually familiar with square of the side. Meanwhile, for the rectangle, we didn't call each side as side because they have two unique of each side, which is width and length. So that's why we put the area as, like you said before, what's that?
What?
How to measure the area of the rectangle?
This times the length by the width.
Okay, length and the width. Okay, cool. That's three shapes that we already learned. Which one is actually really hard for you to understand? I think triangle is easy for you because you already recognize that triangle is half of the rectangle, isn't it?
Yeah,
But which one that actually is still hard for you to understand? Probably you found something
I
still
think like
confused.
it's all like the same because I've already learned it before. So I think nothing. So
Nothing that is really hard for you to understand, yeah?
yeah,
Okay. Now, before I conclude this lesson, let me try to put it another triangle first. Okay, all triangle, for as long as you could identify the height by knowing the top of the triangle, and you also have the base itself, you can actually measure all the area to whatever kind of triangle. Okay, so even though it's like segitiga sama kaki, segitiga sembarang, segitiga sama sisi, all of them is actually possible for you to measure uh the the area itself. But the difference is like this. Previously, we only learned. Let me try to zoom it in. I think okay. Just assume that you only see this area. Okay, so this is a triangle that we already learned. Not a total triangle like being visualized like this, right? If so, how do we actually measure them? Ah, okay. If you think there are two triangles right here, you're not wrong, but that's why the base would get affected. The base right here. If you only count the base only on this part, you would lose the other side because sometimes we are being manipulated by once we know that the height itself is oftenly being cut in the middle of certain triangle means that we need to only measure half of the base. That's why we found the whole area. But it's actually not true. If let's say that the height is actually being somewhere in the middle of the triangle, we need to also include the length of this part of this base as part of our calculation. So in this case, we have base, for example, as 10 meters and the height is 6 meters. The formula would apply the same, but the way that we actually should be really careful when it comes to actually understanding the pattern of the triangle itself, right? Previously, we only recognize this kind of triangle. We apply the formula because we see that, okay, segitiga siku-siku, this is the kind of applicable to all triangle. But once you see a very tricky part, especially when you are facing segitiga sama sisi, for example, the top is right here, right? That's why you cut it half in the middle way because the top is right here. Do not measure the area only on this part or maybe only on this part, but the whole base is the total. This is the base. First base this to this is the second base. In order to get the whole area for that triangle, you have to add them all into the calculation. And then you could use the formula of the triangle. Do you understand at this rate?
Mm, not really.
Not really. Okay. Let's just try to distinguish them. Okay. First, let's get back to the way we identify a triangle measurement. Once we know the top of the triangle, and then we draw dot line like this, most of the students would only measure this triangle or this triangle because at the start they only see, how do I say, segitiga siku-siku saja, segitiga siku-siku saja, this one or this one. Let me try to use another. Both. Sometimes consider this as two triangle, not one triangle, right? Because once we draw a dot line between the top and the base, it seems there are two triangles. It's not actually wrong, but once we actually only measure the area of one of them, that's where we actually uh, comes to the fallacy, to the false answer. If let's say I'm gonna use this color as part of the way we try to measure the triangle itself, the formula will still be the same. Half of the height and the base, right? This one is base and the height itself. Am I correct?
Lebih
Using
what?
this,
Oh,
am I correct using this formula?
mm, yes.
Yes. Okay. But also at the another side of this triangle, there is another triangle with the same height, 6. They also have the base, right? The formula will still be the same, right? But if you only calculate this base, you would definitely have the wrong answer. If you only calculate the area of the triangle only using this base, not this as well, you would get the area of this triangle. Let's try to name it as the second triangle. If you only put the base in this color, you only have the area of this. That's why I said to you, if you want to calculate the whole area of this triangle, especially when it comes to the top point, is somewhat in the middle of the triangle instead of being at the edge, right? At the beginning, we recognize the height is something top to the bottom and it is on the edge of the triangle. Uh, in this case, it's totally different. It's totally different. Same triangle, but totally different. It could be told as like there are two triangles. This is the first one. Ah, let me try to use black color for you to see. This is the first. This is the second. Each triangle is actually connected to each other. So there are two triangles that are actually being connected, right? And then the height that I use right here is actually the total of the base that I use right here is actually the total from the base of the first triangle as well as the base from the second triangle. That's why, let me try to use this one. That's why I draw a line right here to let you know that this is a base for this triangle. So even if the height of this triangle is 4, it doesn't mean that you only have to use this base. No, you could use the base only right here, but you have to add them all. Ah, no, this one is confusing. Let me try to. Ah, ah, so it's less confusion. Okay, do you get it now?
Uh, I think yes.
Okay. Now, the second simplest way when it comes to the base itself is just try to put a ruler, right? Especially when you don't know what's the length of that base. Okay, most of the case, or exercise would put you like this. For example, the height is 3. It was being placed like this, not here. That's also the confusing part. So you have to be careful on that. If the case is any number on any triangle being put at near edge like this, or maybe it was being placed like this, means that it only refers to this base, this tree. If this number 3 being placed on this right side, it means this side. If this tree refers to this side, this area is actually still left unknown. You have to calculate it. That's the same thing goes conversely. If let's say I put 3 right here, this base actually left unknown. So you have to calculate it. But if let's say 3 was being put in the middle like this, or maybe like this, mostly it actually refers to all base. So you don't have to worry about calculating your measurement of area of the triangle. You could simply put it like half of the 3 times 4. Ah, that's the kind of thing that's really need you to pay the attention. You can draw the first and the second triangle. You could measure with your ruler from this edge to this edge. Or if let's say you only have the information for this base, for example, I put it as 3 meters, you could actually calculate it for the rest. For the rest. Okay. Now, do you have any questions so far? Or still confusing for you?
No.
No, not that hard, right? Don't worry, we are going to put it into exercise on how tricky the triangle that is. But at least you begin to realize that actually uh something that is somewhat tricky, especially on certain shapes. That's why for some exercises, most of the students would be get trapped, and I don't want you to be one of them. That's why I try to explain you like this. Okay, I think that will be it for our lesson tonight. Uh, for the next lesson, I believe on next Tuesday, I'm gonna try to put like usual the verbal exercise. Let's try it again. I think that was fun to also, memorize as well as try to communicate the way you understand things. If let's say that you actually understand things differently, I'm gonna try to put the way to say it correctly. maybe your concept was right, but the way you communicate it was a bit twisted, right? That's why there is a misunderstanding sometimes when it comes to the explanation. But don't worry, even if let's say that you understand it differently, which is probably wrong, I'm gonna try to put a simplest way to explain it. Hopefully, that it would help you to correct the understanding as well as to understand the lesson itself. Uh, or maybe you have another method for you to help yourself in memorization. Do you need more exercise in writings, for example?
Uh, no.
No, verbal would be enough for you, right?
Yes.
Okay. Probably I'm gonna need you as well to have your paper as well as your pen in the next Tuesday. Okay? So in case that you forgot about what I said to you before, especially when it comes for you to calculate something, right? It would be helpful for you to write it down on paper. Okay?
Okay.
Okay, sip. If that's all, I think that will be it. Thank you so much for attending the class, as well as very well prepared. You have taken your shower as well as trying to, fully having your attention to this class. Uh, See you again on the next Thursday. Bye bye, Vidi. Have a good night.
Bye-bye.
Bye.
Bye bye, Ibu.
Bye.